Hi everyone, my name is Lydia and together we'll be learning econometrics in the What I Wish They Had Taught Me About Econometrics video series. In the first video of the introductory jargon bits, we learned about a few things to keep in mind, especially about the population model. This video is going to be about types of data you could work with and how the population model language changes. This is going to make it a little bit more easier for you to understand why the population model and the way that we write our generic model changes depending on the kind of exercise that you are thrown at. Type of data you could work with. So we've got cross-sectional time series panel data. From the last video, we know that the generic way we're going to write a model is going to look y equals beta 0 plus beta 1, some x1, and I'm going to stop here just for the sake of the exercise, plus the error term. You can add as many x variables as you want after that. Cross-sectional. The way that you see the generic model, sometimes it will indicate to you that you could be working with cross-sectional data. Sometimes we don't put it just because it's sort of like an underlying rule that, okay, we're working with data that it's like only at the individual level, so we don't really need to add any identifying elements to this generic model for us to be thinking of like cross-sectional or any other types of data, okay? So for cross-sectional data, what you have to understand is that the unique identifying element of it is the individual level. And when I say individual level, that could be a firm, that could be a student, that could be a country, depending on the kind of data, like how macro or micro the level of your data is, but it's always at an individual level, meaning that every line which counts as an observation is basically your individual, your unique individual. More concretely, think about the Excel spreadsheet where your data will be stored. This is also how your Stata or R spreadsheet will look like once you browse the data in that particular software. And for cross-sectional, it's going to be the first column is ID, and any other column could be here. This is where you store your Y variable data, your X1 variable data is stored here, and maybe X2 variable data is stored here. So what happens in the cross-sectional case is that you've got student 1, let's say, then student 2, then student 3, and so on. It could be that every student is uniquely identified by either their personal email or personal student ID number, or you could have an acronym for if like the ID was actually country, an acronym for the specific country and so on. But what is important is that every single line that you have here is giving you some information on a particular individual. So line here is giving you one information on student 1. This line here is information on student 2 and so on. There is no other line where you have student 1 appearing again. Okay, so all the information available on student 1 is going to be all in this one line in here. And that's how we say that ID is your uniquely identifying information in here. How do we write the population model based on that? Well, it's going to be, since every Y and X is a unique value that is associated with that unique entity, unique individual, then yi is equal to beta null plus beta 1 x1 I plus error term I. Notice very carefully, so we've added the i's wherever we have the y and the x variable and also in the error term. Now, for time series, the uniquely identifying dimension is going to be time. And what do I mean by that? Well, you could be having daily data or monthly data or quarterly data on a particular variable, let's say for a particular company or for a particular country. So in here, for instance, what you would have is no longer ID on your first column, but time, because remember, time is your uniquely identifying dimension. And let's say that it's daily, so it's going to be the 20th, let's say, of March, and then we've got the 21st of March, and then the 22nd of March, and so on. And let's say that I am looking into prices of avocado, and I check the prices of avocados everywhere. Obviously, the prices of avocado are not going to change daily. If you were to pick like prices of any currencies, would have been a lot better. This is just for demonstration's sake. So keep in mind, just as we said for the previous one, that the 20th of March is what's identifying any information that we have on the 20th of March and should be on that one single line. That means that if you ever see another line that says 2003 here of that same year, it means it's going to be wrong, okay? So you need to do something to your data to fix it. I didn't put the year here, but let's say that this is 2025 and the same was here 2025, then that would have been a problem. If you have 2003 but year 2024, that wouldn't have been a problem, okay? So how will this change the population model? Well, now every y variable is at a specific date, so at a specific time. So yt equal to beta null, beta 1, x1 t plus epsilon t. Okay, so notice what we've done to the y variable and the x variable and the error term. We've added the t. Ultimately, panel data. So panel data, you already know, it's a combination of cross-sectional and time series. What changes in here is now the uniquely identifying dimension is no longer simply individual or simply time, but it's a combination of the individual and time. So it means that every single line in your Excel spreadsheet or data spreadsheet is going to be a combination of both. So if we go to our usual Excel spreadsheet in here, it means that we're going to have an ID column and we're going to also have a time column. So individual one at year one is going to have its own line, and then individual one at year two is going to have its own separate line, individual one at year three its own separate line. And let's say we only have 3 years for now, so once we're done with all the lines for the first person, we continue to the second person. So second person, we observe him in year one, second person in year two, second person in year three, and then we move on to the third person, and so on. So look very carefully. What is uniquely identifying every single line in here is the combination of both the ID and time. Okay, so that means that if at some point you had another line in here where you have 1 year 2, then whenever you try to run any kind of methodology you're going to try is going to give you errors because you can't have this and this in 2 separate lines, okay? Given this information, now we're going to write our population model as yit equals to beta null plus beta 1 x1 it plus epsilon it. So I'm going to highlight again, it. Look very carefully and notice the subscript it or it, meaning like the uniquely identifying dimensions for every type of data, is only being associated either with your y variable, with your x variable, or with the error term. The betas, they do not take any of these its or t's, okay? The betas are estimated only once. They will apply to it doesn't matter whichever individual you're looking at whatever time you're looking at. It's the beta 0 and the beta 1. Once they are estimated and you have like a very specific beta null hat and beta 1 hat, they apply to all individuals or to all time dimensions, okay? That's why they don't have the I, the T, or IT subscripts with them. I hope this was helpful and the Excel gave you a bit of a visual representation of like why do we need to be aware of like the uniquely identifying dimensions and why sometimes you will see a model written in either one of these ways. Keep in mind, the moment that you see cross-sectional time series or panel data and you correctly identify what you're working with, it makes it a lot more easier for you to also identify what will be the best method of estimation that you can use for the kind of data that you're given. Hope this was helpful, and I'll see you in the next video.